The internet, the globally interconnection of networks, routers, and protocols flinging data around the planet, has touched almost every aspect of our lives. It is arguably the greatest invention of 20th century. Unfortunately, it also a flawed one. The existence of a $173 billion cybersecurity industry highlights the scale of the data protection and privacy issues that consumers, business, and governments face when using the internet. But what if there was a 21st century alternative that promised to secure the movement of data more completely than ever before? What if there was a quantum internet that came with the promise of being virtually unhackable? That's precisely what the US Department of Energy (DOE) has said is to be built a new era of communications and push the US to the forefront of the global quantum race. What's more, the DOE announced during a July 23rd press conference a working prototype is expected to be completed within the next 10 years. The US Department of Energy has announced a plan to make a quantum internet it says is virtually unhackable. This is definitely a long-term plan that will require new kinds of engineering and technology, not something that will be implemented next year. Although headlines and research have focused on the power of quantum computing, we are far away from any practical and recognizable computer powered by quantum phenomena. The idea of quantum network, the DOE says, it's far closer to our reach. It works through two quantum phenomena. The first is quantum entanglement, where two particles can become so inextricably linked that no matter how much distance separates them, changing the properties of one will change those of the other. And since that communication happens instantly, a quantum internet could be much faster than today's network. The second phenomena is quantum superposition, where a particle can exist in two different states at once. This is what enables tighter security of the information shared across a quantum network. Information is encoded into entangled pairs of photons in a superposition of states. In data terms, that means they represent both a 1 and a 0 at the same time. The Department of Energy statement is somewhat more sensible, in my opinion, when it talks of relying upon the laws of quantum mechanics to control and transmit information more securely than ever before. More securely, not completely securely. Then it goes and spoils everything by using the phrase virtually unhackable networks. A quantum internet will not be unhackable. It will likely be much harder for anyone to interrupt on the transmission of encrypted data using quantum key distribution. But that's not to say it's impossible. Yes, the decryption keys are sent using qubits in a quantum state, which means that if a hacker were to attempt to observe them in a transmit, then they are altered, they collapse, the hack attempt is visible and the keys are discarded, new ones generated, and the process starts again. Great in theory. In practice, there are plenty of quantum key distribution networks operating already. It's the weak spots such as optical fiber termination points, switches, and connections that will be targeted by hackers. Security does not involve one single point of attack. Think of how rapidly fiber optic internet increased our connection speed capacity while computers have remained basically the same. And a quantum internet could rapidly increase even over high fiber speeds.